Welcome to this video on linear equations and linear systems. In this unit, students write and solve linear equations in one variable. This includes equations in which variables are on both sides of the equal sign, and equations with no solution, exactly one solution, and infinite many solutions. Here are the essential vocabulary words that will be introduced in the unit. Constant term, system of equations. Students will begin this unit by working on solving linear equations. We can think of a balanced hanger as a metaphor for an equation. An equation says that the expression on either side have equal value, just like a balanced hanger has equal weights on either side. We can do this with equations as well. Adding or subtracting the same amount from both sides for an equation keeps the sides equal to each other. What is the weight of a square if a triangle weighs 4 grams? 8 grams. There is one more square on the left than on the right, and two more triangles on the right than on the left. So the square on the left balances with two triangles on the right. Students learn to work with equations that have variables on each side. Students recall a representation that they have seen in prior grades. The balance hanger. The hanger is balanced because the total weight on each side, hanging at the same distance from the center, is equal in measure to the total weight on the other side. Students will work with systems of equations. A system of equations is a set of two or more equations where the letters represent the same values. For example, say car A is traveling 75 miles per hour and passes a rest area. The distance in mile it has traveled from the rest area after t hours is d equals 75t. Car B is also traveling toward the rest area, and its distance from the rest area at any time is d equals 14 minus 65t. We can ask if there is ever a time when the distance of car A from the rest area is the same as the distance of car B from the rest area. If the answer is yes, then the solution will correspond to one point that is on both lines, such as point 0.1, 7.5, shown here. 0.1 hours after car A passes the rest area, both cars will be 7.5 miles from the rest area. We could also answer the question without using a graph, since we are asking when the d values for each car will be the same. We are asking for what t value, if any, makes 75t equals 14 minus 65t true. Solving this equation for t, we find that t equals 0.1 is a solution, and at that time the cars are 7.5 miles away, since 75t equals 75 times 0.1, which equals 7.5. This finding matches the graph.